Today I'd like to show you how the GSMA interoperability test platform can be used by hub operators to streamline their onboarding processes and certify DFSP implementations to ensure a high quality throughout the network. We're going to follow Mr. James Red, who's in charge of onboarding and certification at ColorHub. ColorHub have had problems recently with partner implementations when it comes to handling error messages. Although happy path flows tend to work without a hitch, they've observed that many implementations are not handling error notifications correctly from the hub. To address this, James is going to create a new test case. First, he exports the existing happy path test case. Next, he re-imports the test case so that he has a clean copy to work with. Once it's imported, he edits the test case to reflect the behavior he wants to test. First, he changes the test case name and slug to find it again more easily. The behavior should now be negative, and the description should be updated to show that he is testing the case where the remote DFSP does not respond to a request for quotes. Next, he reviews the test steps. He wants to simulate the case where the remote DFSP does not respond, so he identifies the put quotes step and then deletes it. Next, he adjusts the following step, which was originally a forwarded message from the hub to DFSP1. Now it needs to be an error notification. The step path is updated so that the correct API specification validation can be applied. The step pattern is used for the test platform to identify incoming requests. Next, he updates the automated tests which are applied to the request to ensure the hub is correctly generating the error. Firstly, the quote ID still needs to be checked, but the regular expression that is used needs to be updated for the new error URL. The request no longer specifies an amount or a currency, so instead, James updates that test case. He wants to ensure that the error code is always sent to be the value 2004. Finally, he removes an unnecessary test for the ILP packet. Next, he moves on to the simulated request definition. This is used by the test platform to generate simulated requests. Again, the request URL needs to be updated, and he adds a small delay to simulate waiting for an unresponsive participant. The request headers mostly can stay the same. The FSP IOP URI header needs adjusting again. And the FSP IOP source header should now be simply switch. He removes the signature for the error notification and updates the destination to be the same as the previous step's source. Finally, the HTTP method will always be put. The request body was previously simply forwarded from the previous step. James doesn't want that behavior now, so instead he deletes it and includes a sample error payload. Finally, the response. James wants to make sure that the request is well received by the DFSP, so he keeps the test for a 200 status code. The response headers and body were empty, so they don't need updating. To review, James checks out the test flow. He sees that the test will perform the parties stage, then post quotes, and then the error notification. He notices that the transfer step is still scheduled, although they should not happen after an error is encountered. He returns to the test steps page and deletes each step. Now he checks the test flow one more time and is happy that things look good. He heads to the versions page and publishes his changes as a new version. New participants will use the latest test case version automatically. Now that he has created his test case, James can invite DFSPs to execute it. He creates a new user group for one of their new partners who are ready to start onboarding, Cyan FSP. He adds an email filter to ensure that individuals who do not have a Cyan FSP email address cannot accidentally join the group. To help out with testing, James wants to set up a group environment for Cyan FSP. This will contain some variables that are used during the test case execution. In this case, the ColorHub switch has set up one particular phone number and FSP IOP ID to test with, so he provides those details here to avoid Cyan FSP needing to enter those details themselves. Additionally, JWS signatures will be generated by the test platform, since the requests from the remote DFSP are simulated. To generate these signatures, James uploads a private key and also uploads the public certificate to automatically verify that these signatures are correctly generated. Finally, James is ready to invite someone to execute these tests. Within the CyanFSP group, he creates an invitation for the first user, Louise. Louise receives an email inviting her to join the platform. She clicks the link and registers an account. Immediately, she is ready to create a new test session. Test and manual sessions are private sessions, designed to help DFSPs refine their implementation, but Louise is already confident in her work. She jumps straight in and creates a certification session, where the results will be shared with ColorHub. The platform asks Louise a few questions to help select the correct set of test cases for her certification. She opts to be tested on both happy and unhappy flows. She enters a session name for her own reference and then continues. In the next step, she sets up configuration details for CyanFSP's implementation. She picks DFSP1, indicating that she wishes to be tested as a DFSP. The component she does not select will be simulated by the platform. She enters a URL which the platform can use to reach the CyanFSP API. Next, Louise needs to enter some variables to customize the test case for her test environment. Some variable values have already been provided by ColorHub, so she selects the group environment and clicks Merge. She provides values for the remaining variables that are important to her, leaving blank any values for which she is happy to use the default values. For the JWS variables, she doesn't need to upload a private key, since she will be generating the signatures herself. She still uploads a public certificate to prove that the signatures are correctly generated. Finally, the session is ready. She reviews the details, then gets ready to launch a transfer. First, she copies the URL provided by the platform and configures her own system to use this URL to reach the hub. With that done, she picks a test case to execute and clicks Run Test Case. The platform is now listening for her requests, and she initiates a transfer from CyanFSP. Since James's new test case is active, the test platform simulates a situation where the remote DFSP does not respond. Instead, the hub generates an error. At the end of the test, she notices that the final step has failed. Clicking through, she can see that CyanFSP has responded with an HTTP 400 status instead of an HTTP 200. Luckily, she knows how to fix the problem. She edits a configuration file within her system to modify the behavior of the response handler. When this is done, Louise launches a new test run and initiates a second transfer. This time, everything passes and the correct status code is sent. Confident, Louise moves on to the Happy Path test case and launches a test run for it. She initiates the transfer, and this time the test platform simulates correct behavior for the remote DFSP. The transfer is able to proceed successfully. Once the test has passed, Louise has a full suite of test results and is able to submit them for review. James now receives an email informing him that there are new test results to review. He clicks the link and is able to view the full details of Louise's test. In particular, he wants to manually check to review the status code of the final response in his new "unresponsive" test case. Satisfied, he returns to approve the test results. Louise now receives an email to view the results of her application. She sees that the status has changed to approved. This indicates that the implementation has now been certified by ColorHub, and she can now work with James to proceed with the next step of onboarding into the network.